We're starting off today's lesson with a reminder of domain and range for our inverse functions. As they're quite new to us, it's going to take a little bit of getting used to. For sine inverse as well as cosine inverse, the domain is values between -1 and 1. We cannot input anything into the inverse function that is outside that domain. It has to be between -1 and 1. The range for sine inverse as well as tangent inverse is from -90 degrees to +90 degrees, or -π/2 to +π/2. Cosine has a range from 0 to 180 degrees, or between 0 and pi radians. And the domain for tangent inverse is all real numbers. Keeping all of that in mind, I know that's a lot to keep track of, we're going to look at composition of inverse functions now. Typically, when you have two inverse functions like squaring and square rooting or multiplying and dividing, they completely undo each other. Whatever you input, you get as an output from the inverse function. But when we have restricted domains like we do with our trig functions, it's not that straightforward. Starting off with our first composition, we have tangent of the arctangent of -5. So we need to think, is -5 in the domain of the arctangent or tangent inverse function? Can we put -5 in? The answer is yes. The domain for our tangent inverse is all real numbers. And then we think about the range of the tangent function, which is also all real numbers. So in this case, it is pretty straightforward. Tangent and arctangent cancel each other out, leaving us with that -5. This next one is not straightforward at all. Sine inverse obviously is not the inverse of our tangent function, so we're going to have to do a little bit of work on this one. Tangent of 3π/4. Thinking about our unit circle and using those reference angles, the reference angle would be π/4, where sine and cosine are equal to each other, so our tangent value is 1. 3π/4 is off in the second quadrant, where tangent is negative, taking the sine inverse of -1. Can we put -1 into the sine inverse function? Yes, it just barely fits in our domain from -1 to 1. So now we're thinking unit circle, where is our sine value, our y coordinate, -1? And that would be down here. Now we have to think about which value, which angle of rotation is that is within the range of our inverse function. Normally we think of that as 3π/2 rotating in the positive direction. However, that is outside the range of our inverse function. Our inverse function thinks of it as a negative angle of rotation, which would give us -π/2. Again, mixing things up a bit, cosine and sine inverse are not inverses of each other, so we're going to have to think unit circle, where on the unit circle is sine equal to a +1/2. Sine goes in order 1, 2, 3. So here we are at π/6. We're going to input that into our cosine function. And at π/6, cosine is √3/2. Our next one looks like it should be straightforward. We've got the arcsine of the sine function. They should just cancel each other out, leaving us with 135 degrees. But with these restricted domains, that doesn't always happen. 135 degrees is not in the range of our arcsine function, so it is not the angle of rotation that our sine inverse or arcsine will give us. So we have to think about what is the sine value at 135 degrees. Over here in our second quadrant, using that reference angle of 45 degrees, sine is √2/2. And in the second quadrant, sine is still positive √2/2. So we'll input that √2/2 into our arcsine function, which brings us back to where in the range of the arcsine function, which is from -90 degrees to +90 degrees, would that sine value be √2/2, and that happens at 45 degrees. So the arcsine of the sine of 135 degrees doesn't just cancel and leave us with what we inputted. It has to give us a value in the range of the arcsine function. Another one that looks like it should be straightforward, cosine inverse of the cosine function. They should just cancel each other out. But we have to make sure that that input value is in the range of the inverse function. Negative pi over 3 is in the fourth quadrant. Cosine is positive in the fourth quadrant. What I'm going to do this time is, instead of finding that exact cosine value, we're just going to think about where it's positive and negative and get our answer in the correct range of the inverse function. Cosine is also positive in the first quadrant, so we would have the same cosine values at positive pi over 3 that we would at negative pi over 3 for our cosine function. Negative pi over 3 is not in the range of cosine inverse, but positive pi over 3 is. As a reminder, cosine is the one with the different range. It's from 0 to pi, or 0 to 180 degrees. One last example, we have sine of the arctangent. So this one, of course, is not straightforward. We have to figure out what the arctangent of negative root 3 over 3 is. Our arctangent, or tangent inverse range, is from negative pi over 2 to positive pi over 2. Tangent, of course, is negative in the third quadrant, and we need to think about which angle gives us that root 3 over 3 value. Remembering in the first quadrant what those ordered pairs are, cosine goes backwards 3, 2, 1, but we know it's not the 45 degrees because tangent is 1 at the 45 degrees. So we really just need to figure out, is it the 30 degrees or the 60 degrees? Sine, of course, goes in order, 1, 2, 3. And when you look at these coordinates, think about which one does the root 3 get flipped, and you need to rationalize it. And it's this one down here at pi over 6. Real quickly, let me remind you, tangent is sine over cosine. So you end up with the radical in the denominator. The 2's cancel, and in order to rationalize this one, you move it up to the numerator. With our pi over 3 one, tangent value at pi over 3, sine over cosine, the root 3 stays in the numerator. You don't need to rationalize. The 2's cancel. You get root 3. So you should be able to just look at those coordinates and figure out which one do I need to rationalize. Or you can try and memorize the tangent. It's root 3 over 3, 1, root 3. In either case, the arctangent of negative root 3 over 3 would be in the fourth quadrant at negative pi over 6. The sine value at negative pi over 6 in the fourth quadrant is negative 1/2. You have 3 U-try questions. The first 2 are similar to the notes. The third one is evaluating with your calculator the arctangent or tangent inverse, and make sure you're in radian mode.